The spiral arms of galaxies are among the most beautiful and iconic structures in the cosmos. They evoke the elegance of order, sweeping arcs of stars, dust, and gas, gracefully winding around a glowing core. But beneath that beauty lies a mystery. How do spiral arms form, and why do they persist for billions of years? The Triangulum Galaxy, also known as M33, offers a fascinating case study. Unlike galaxies with rigid symmetrical patterns, Triangulum shows a complex, asymmetric spiral structure, with arms of varying length, thickness, and brightness. What creates such a pattern? The leading theory is the density wave model, which suggests spiral arms are not made of fixed stars, but rather moving waves of increased density, like traffic jams in space. As stars and gas orbit the galactic center, they slow down when entering a spiral arm and speed up when leaving, creating the illusion of a rotating arm. But Triangulum challenges the simplicity of this model. It seems to have multiple spiral wave patterns operating at once, with different pitch angles and rotation speeds. In other words, it's not a single melody, but a symphony of overlapping rhythms. Some arm segments move faster, others slower. Some wind tightly, others loosely. This suggests that spiral structure is dynamic, constantly evolving. Recent computer simulations show that internal instabilities, such as local gas compressions or turbulence in the disk, can also generate spiral patterns. These instabilities may fade and reform, creating temporary arms or arm segments that appear and vanish over time. In addition, the passage of massive gas clouds, satellite galaxies, or even dark matter clumps can disrupt the regular spiral and create kinks, spurs, or new arms. In some galaxies, a central stellar bar plays a key role in spiral formation, acting like a lever that drives density waves outward. But Triangulum lacks a strong central bar, setting it apart from barred spirals like the Milky Way. So what maintains its graceful swirls? One possibility is that local gravitational resonances, regions where orbital speeds match wave speeds, reinforce the pattern over time. Another is that feedback from star formation, such as supernova shocks and stellar winds, reshapes the surrounding gas and maintains spiral symmetry. It's also possible that the dark matter halo surrounding Triangulum plays a subtle role. Its gravitational influence may stabilize or destabilize certain regions, guiding the overall form of the spiral. This dance of arms is not just aesthetic, it's essential to galactic life. Spiral arms are stellar nurseries, where gas is compressed, cooled, and turned into stars. The most massive and luminous stars are found along these arms, lighting up the structure like cosmic lanterns. Yet these stars live short lives, just a few million years, before exploding as supernovae, feeding energy back into the arms. This feedback process regulates star formation, balances gas pressure, and may even sustain the spiral wave itself. In Triangulum, the star formation rate is high relative to its mass, indicating that its arms are active and vibrant. Observations from telescopes like Hubble, Spitzer, and the James Webb Space Telescope are helping to map these regions in unprecedented detail, revealing how stars, dust, and molecular gas interact across spiral lanes. These insights show us that no two arms are alike. Some contain large, giant molecular clouds, while others are rich in older stars. Some spiral arms branch or split, like rivers forming deltas. Others twist sharply or fade into wisps. This complexity suggests a chaotic elegance, a structure built by order, but shaped by turbulence and time. And as Triangulum rotates over hundreds of millions of years, its arms are rewritten again and again, each rotation painting a new chapter in its spiral history. What we see today is only a snapshot, one frame in a cosmic movie that stretches billions of years. In the far future, Triangulum may develop new spiral arms, lose old ones, or even transform into a different galaxy type altogether, especially after potential mergers. But for now, its spiral pattern continues to mesmerize, a galactic fingerprint of forces we are only beginning to understand. The dance of the arms is more than motion. It's the rhythm of creation.